Hello again. In this fourth and final segment of our program, we're going to examine another key hazard that affects a large group of United States industrial workers called flash fire. In general terms, a flash fire is an unexpected, sudden, intense fire caused by ignition of gases, ignitable liquid vapors, or combustible dust. It is characterized by high temperature and short duration. Flash fires are sudden and unexpected. Although they only last for a matter of seconds, they can quickly reach excessive temperatures that can ignite clothing. The purpose of FR clothing in a flash fire situation is to provide a few extra seconds of escape time and to reduce body burn injury over what a worker would likely sustain in conventional work clothing. Typical industries where flash fire risk is more prevalent include oil refineries, oil and gas drilling and chemical plants, as well as manufacturing facilities where combustible dust hazards might be present, including coal, flour, sugar, and metallic dust, to name a few. Let's look at an example of a flash fire. The primary test designed to measure a fabric's protective level against flash fire is ASTM F1930, more commonly referred to as the mannequin test. This test method is designed to evaluate the protective performance of material when exposed to simulated flash fire in laboratory conditions. The test is performed using an exposure heat flux of 2 calories per square centimeter per second for 3 seconds of exposure time. Here's how the test works. The mannequin has over 100 heat sensors distributed uniformly around its body. The mannequin is surrounded by at least 8 propane burners. In order to test a fabric, you need to create a coverall out of the material being tested and wash it once. The standard actually outlines the size and design of the coverall and how it is to be washed. You put this onto the mannequin over a set of 100% cotton t-shirt and briefs. So, you have the mannequin dressed, and then a simulated flash fire is initiated. The burners are lit and project flames onto the coverall for 3 seconds. During the fire exposure, the heat transmitted through the material is measured by those 100-plus sensors. Using this collected data, a calculation is made that is used to predict the degree of second and third degree burn injury. Let's see what this looks like. As you can see, the mannequin is totally engulfed in flames for the entire 3 seconds. But once the flames go out, you see the FR coverall has not ignited and does not continue to burn like a comparable non-FR version would. Here is an example of the 3 different burns on the mannequin. Here, you have percentage of body burn, for example, 20% or 40%. And along the bottom is how long the test is run, from 1 to 4 seconds. It shows the increase in predicted second and third degree body burn from 1.5 to 4 seconds. For example, this blue line shows a predicted 25% body burn after 3 seconds. This yellow line shows just over 50% body burn at 4 seconds. As bad as a 25% body burn would be, when you're up against the intensity of a flash fire, it's about survival. And an increase in body burn area has been shown to directly affect survival. This chart, based on an American Burn Association study, shows the correlation between percentage body burn and survival by age category. For 20 to 29-year-olds, you have a very high survival rate at a 25% body burn in the high 90s. Of course, at a 75% body burn, chances of survival drop off, particularly if you're older, with only a 15% chance of surviving for someone in their 50s. As we discussed earlier, the key standard that addresses FR clothing performance criteria against flash fire is NFPA 2112. Well, that's about it. We've covered some of the basics you need to know when making a decision on what type of FR garments are best for you and your company. I hope you found this tutorial useful and look forward to seeing you all again soon. Thanks for watching.